and this is my video about my time at UF for Surf 2023. Man, this video starts stupid. Where am I? My name is Riley, and I'm a photo poly student at Photo Polytechnic University. And I will be graduating in 2026, maybe 2025. That's something to be worked out with my advisor in environmental engineering. As far as hobbies, I mostly just rock climb and go to the gym, hang out with my friends. Uh, and I like to learn a lot of random stuff. I have, you know, the cheapest books I can find on things like monkeys, ecosystems, all over the place in my room. This past year, I was a Physics 2 TA and tutor. I will likely do something similar, not exactly Physics 2, but maybe try to do some upper level classes as I go forward. I'm an undergraduate researcher at my home institution under Dr. Malik Chaussee, and I'm the oldest of four. Why am I here? I went to UF because I saw an application. I thought that it looked like a super cool opportunity, and I find biological engineering to be extremely cool in that, like, the part that kind of, when you're studying environmental engineering, most of it is relatively focused on infrastructure, and it's kind of like civil with a flair of chemistry. And I don't dislike it, but I think that my passion lies within ecosystem, environmental concerns with a large focus on biological systems and properties, which is why I decided to come here for a research internship in biological engineering. My time here, I created version 0 of IFWASTE, which I will get into more later. I mentored 2 high schoolers here for SSTP. I don't remember the acronym, never learned it, but essentially it was 2 high schoolers here to do almost the same thing I'm doing, just on a slightly lower level, and I think it was a great experience for me and for them both to get to learn and talk about those things. I got to gain a lot of experience in my research and gain a lot of confidence too in my capabilities as a researcher and a programmer especially. And one of the hopeful things that comes out of this is I will be a co-author on a published article and paper, which will look very good for me in the long run, as well as, kind of take pride in the work I do. And it also got my foot in the door for biological engineering and programming and modeling. So kind of like a bunch of big hitters there that really helped me out. So what was my work this summer on, and what happened? What did I do, and what was my job? So, like I mentioned earlier, I created a version 0 for the IFWASTE ABM model, and here is just a general overview of what the model is. In start, it's everything needs a use, and the important thing here is that anywhere between 33 and 40% of all food made and brought to the United States gets wasted, and 17% of the edible food that's lost and wasted is wasted at the consumer level after me and you and others like us buy it. And the problem is the solutions are very complicated and very complex because humans are very complex. And I mean, you just try to predict what I'm gonna eat for breakfast tomorrow and whether or not I'm gonna finish it all. Like, it's a challenging thing to do. And even when people know the best practices, they're not always gonna do them. Like, like maybe you know that if you don't eat that tonight, it's gonna go bad, but you don't want it. And similar things like that oftentimes lead to unnecessary food waste. And to create solutions, us as researchers need to know what is causing these behaviors and why. Because if you just have like a linear regression model of outputs, it doesn't actually give you real insight into what's happening. And the if waste project aims to model these causes and behaviors in their relationships. So what is the if waste model? It is an agent-based model, which in short is, instead of a traditional mathematical model where you make a bunch of assumptions and run and make an equation, an agent-based model runs in the sense of, I know that each person is going to act in a way in this fashion, and so I'm going to implement a bunch of people that are going to act in this fashion, and then let them run in an environment and see what happens. And this way it allows us to have more control over the variables and the setting, as well as exactly what is causing, in layman in the terms of agent-based modeling, we call it emergent behavior. So the purposes and goals were to use food waste, or to find food waste composition and generation estimates uh, through using things like the theory of food behavior and the motivation, opportunity, and ability model, which essentially say that your environment, as well as how much control you think you have, the social norms around you, and your personal thoughts on an action, especially when it comes to the environment, excuse me, is directly correlated to your intent. Where your intent, while it's very closely related to your behavior, it is not perfect, as we all intend to do better at a million things. Like, I intend to work out more, and you know, I don't sometimes. And I'm sure everyone else says something similar as well. The different entities are going to be households, consumers. Currently, we have households and consumers as one body. We assume that all people in a house act as like a conglomerate, which isn't entirely true, but for most things it is. So it's a good enough assumption for us to make for now. We also are aiming to have different kinds of stores. Right now, it's only running with one store that each household goes to. However, from there, it'll be pretty easy to implement multiple different stores, such as delivery, fast food, like a Dollar General, Whole Foods, Publix, anything you can think of. The different processes that we'll aim to replicate are things like educational interventions, social campaigns. Those things all affect these networks of people who will, who may or may not change their actions based on that. And that's what we're trying to look at. At some point, we will get input data from census and actual store data. However, we don't have that at the moment, so it was made, like, the program currently is made with that in mind, but it's not made with that in implementation. Thanks to Dr. Kiker, Omrit, and Emerson, the two high schoolers that I was mentoring before. We have this UML diagram, which isn't particularly important unless you are someone who's interested in how the code works and intends to, try to read it or replicate it. So we can just kind of cruise right on ahead. This here is a simplified version of the layout of the model. It's nothing super complicated. All it says is that we have a house here, and this house is going to go to the store when it shops. When it shops, it gets a basket of food. Some of this food, all of the food, sorry, goes into this data stream, which we will track and use for data visualization to check to make sure our information is accurate, and also to do a mass balance to make sure that we're not losing anything anywhere in the middle. If it's a store-ready item, like something like a pizza, a sub, maybe a frozen item, anything that you can eat as a meal right then and there, we say it goes to the fridge. Whereas anything that's an ingredient goes into the pantry. Sorry. Yeah, I don't like this one. What are my goals for the future? Goals for the future, I have a couple more years. Let's see, 3 more years of school. With a relatively light schedule, I will be spending as much time as I can towards research and extracurriculars. I think I will be working in part on a few clubs. I think I'm supposed to be the leader of a new chapter of the Florida Engineering Society and aim to get more research under my belt as well as get experiences much like this one over the summers. I might come back here. I might try to, broaden my scope, both of which have their pros and cons. Um, Hopefully, I can earn a fellowship. If not, that's okay. I understand most people don't. And then hopefully go into a PhD program in biological engineering focused on modeling and programming in biological or ecological topics, bioinformatics and genetics, because I find a lot of interest in those areas and think there's a lot of use there, or synthetic biology, all aimed in creating a healthier, more resilient world slash ecosystem. Other topics that I find very interesting and would love to look more into are things like are things like battery technology, because there's a lot that needs to be done for battery technology to move forward in our world, as it's the main thing holding back solar. And um, personally, not too big on electric cars, but we still could use electric battery technology to power our public transportation, which would be a big win for all. That's everything I have to talk about today. Thank you for watching.